Good morning to all the students. This lesson is for class 10th for the subject of chemistry, topic percentage composition, empirical and molecular formula, which is covered in chapter 5, mole concept and stoichiometry, starting on page number 86 of your textbook titled Concise Chemistry by Selena Publication, and is being submitted to you on 19th April 2021. This voice is of Mohinisha Thakur. All students may now please open page number 86 of your notebook in front of you. If all students are ready, then let us start with this chapter. All students may now please listen carefully. Percentage composition, empirical and molecular formula. Students, it is the percentage by which of each element present in the compound. Percentage of an element in a compound is equals to weight of the element in one molecule upon gram molecular weight of the compound into 100. Suppose, students, if we will found the percentage composition of carbon in CO and 2H4, so it will be equals to 12 upon molecular weight of that compound, that is 12 plus 16 plus 14 into 2 plus 1 into 4 into 100. So it will equals to 12 upon 60 into 100 and will become 20%. Now we will do empirical formula. So students, empirical formula of a compound is the formula which gives the simplest whole number ratio of atoms of different elements present in one molecule of the compound. Example, if the molecular formula of glucose is equals to C6H12O6. So ratio of elements is equals to 6 ratio 12 ratio 6. So it will be cut by the table of 6. 6 1 the 6, 6 2 the 12, 6 1 the 6. So simplest ratio will come 1 ratio 2 ratio 1. So empirical formula of glucose is CH2O. Now we will do the determination of empirical formula. If the percentage weight of all the elements of a compound is given, then we can find its empirical formula by using the following steps. So number one step is we find the atomic ratio or the ratio of number of atoms present in the molecule of a compound by dividing the percentage weight of the element with its atomic mass. In step 2, if the percentage of one element is not given, then we can find it by subtracting the sum of percentage of other elements by 100. Number 3, to find the whole number ratio from atomic ratio, we divide all the atomic ratio numbers with the smallest number of the atomic ratio. Fourth step is, now we can write the empirical formula by writing the symbols of elements and the ratio obtained. So students, let us solve an example. So here's the example is given, that question: an organic compound has oxygen is equals to 26.24% and hydrogen is equals to 4.92%. Find its empirical formula. So solution for this, that organic compounds certain carbon but percentage of carbon is not given. First we will find that percentage of carbon. So what we will do, that will be, we will subtract the 100 minus 26.24, that is the percentage of oxygen, or we will add this percentage with the percentages of hydrogen, that is 4.92, and we will calculate the percentage of carbon, which is 68.84%. Now let us put the values in tabular form. So you just draw a table in your notebook like this. Draw the columns for element, percentage, atomic mass, atomic ratio and simplest ratio. You will write all the elements which you have given, that is carbon, hydrogen, oxygen, their percentage, that is 68.84%, which we have calculated. Hydrogen 4.92, oxygen 26.24. Now the atomic mass is, as you know, the carbon has 12, hydrogen has 1 and oxygen is 16. Now to find the atomic ratio, what we will have to do, we will divide the percentage by atomic mass. So you will get all the atomic ratio of all the three elements, carbon, hydrogen and oxygen. After finding the atomic ratio, you will find the simplest ratio. So what you will have to do, in the atomic ratio, you will see the lowest value. So the lowest value is 1.64. So this value you will take to find the simplest ratio. You will divide this value to the atomic ratio. Like in simplest ratio, you may observe that 5.74 divided by 1.64. Similarly, hydrogen atomic ratio, that is 4.92 divided by 1.64. As similar, oxygen atomic ratio, that is 1.64 divided by 1.64. On calculating it, it will come, the carbon will have the ratio 3.5, hydrogen will have 3, oxygen will have 1. So to find the simplest ratio, we divide all the atomic ratio by the smallest number, which is 1.64. Since 3.5 is not a whole number, we will multiply all the ratios, that 3.5, 3 and 1 by 2, so that we get whole numbers. So here 3.5 into 2, 3 into 2, 1 into 2, that is equal to 7, 6, 2. Thus CHO, that is equal to 7 ratio 6 ratio 2. So empirical formula will be C7H6O2. Now we will discuss the topic determination of molecular formula. Determination of molecular formula. We can determine the molecular formula of a compound if we know its empirical formula and molecular weights. Steps: number 1, find the empirical weight of the compound from its empirical formula. Number 2, divide the molecular weight of the compound by its empirical weight and find N. Number 3, multiply the empirical formula by this number N to find the molecular formula, that is N is equals to molecular weight by empirical formula weight. So molecular formula is equals to empirical formula into N. Let us solve the exercise 5C, question number 3. So in the question number 3, we will have to calculate the empirical formula. So here the A part will come, C6H6 will 6 will cut, because 6 1 is 6, 6 1 is CH. B have C6H8O3. C will have CH. D can be written as CH2O. Now the solution of question number 4 is molecular weight of CuSO4.5H2O. The atomic mass has given to you, that copper has 64, sulfur has 32, oxygen is 16. Then put this molecular atomic mass of all the elements in the given equation, and you will find the molecular weight of CuSO4.5H2O. So what we will do now, we will write the weight of order of crystallization, that is equals to 5H2O. We will find the molecular weight of 5H2O. So it will come 90. It will come 90. Now, the percentage of water of crystallization is equals to 90 divided by 250 into 100, that is equals to 36%. Now, move on the fifth question, A part. In this question, the molecular weight of calcium, which is CaH2PO4 whole twice, that is equals to 234. As you know that you can calculate the molecular weight of any compound. Now, the mass of phosphorus is given 31 into 2, that is equals to 62. So, percentage of phosphorus, that is equals to 62 divided by 234, that is a molecular weight of CH2PO4 whole twice into 100, and the percentage of phosphorus will come 26.5%. Its B part, molecular weight of calcium phosphate, that is 40 into 3 plus 31 into 2 plus will be 310. So, mass of phosphorus 31 into 2, that is 62. So, percentage of phosphorus is equals to 62 by 310 into 100, that is equals to 20%. So, students, you may observe the solution of question number 7, question number 8, question number 9, question number 11 and question number 14 on page number 5 and 6 of the notes, which is sent on 19th April 2021. Now, I will give you 3 very short questions. You will get a 3 minutes break to write the answers. So, question number 1 is, what is the percentage composition of an element in methane CH4? That you will have to calculate the percentage composition of carbon in CH4. Question number 2, give the empirical formula of CH3COOH. And the last question number 3 is, how can we calculate the molecular formula? Students, now pause this audio for 3 minutes and write the answers in your chemistry notebook. I hope you all have written the answers by now. Let us check the answers now. So, answer number 1 is, firstly you will find the molecular formula of CH4, that is 16. Then percentage composition of carbon is equals to weight of the carbon element divided by molecular weight of CH4 into 100. So, what we will have to put the values of these given term, that 12 by 16 into 100, that is equals to 12, 100 upon 16, that is equals to 75%. So, what is the percentage of composition of carbon in CH4 is? That is 75%. Now, the answer number 2 is CH2O. And the last answer number 3 is N is equals to molecular weight upon empirical formula weight. Students, now I am ending the lesson for today by giving instructions and homework. So, instructions are, students, kindly go through the examples given in the textbook and practice the solved numericals given in the notes. And the homework is, do questions 6, 10, 12 and 13 from exercise 5C given on page number 90. Thank you and have a nice day.